Alright, so next we are going to talk about the physical significance of inductance. Okay, let me take you to the first year chapter. Okay, so we know that what is mass. What is mass? Mass is actually the measure of inertia. Okay, and in the same way, you know that what is analogous to mass, what in rotational motion, what we have studied. Yes, moment of inertia. What is moment of inertia? It is actually the measure of rotational inertia. So in a translational motion, mass is actually the measure of inertia. And in rotational motion, we have studied the moment of inertia is actually the measure of rotational inertia. In the same way, look at this. What exactly the physical meaning of mass and moment of inertia? What is their role in translational motion as well as rotational motion? So they will always try to oppose the change of state. They will always try to oppose the change of its present state. It's a current state. So that is what is mass and moment of inertia. They do in translation and rotational motion respectively. Alright. So now let me tell you something. Okay, let me tell you something. That is in the same way, in the case of inductance. Okay, so you can consider in the case of inductor, the property that inductance is also playing the same kind of role in this case. Okay, for example, when the current increases, it will always try to oppose the change. There will be an induced EMF. This induced EMF will always try to oppose the change of the current, or the change of the flux. Okay, so it will always try to oppose that. So in the same way, for example, here current is increasing and current is increasing. So in increasing current, it will try to oppose the current flowing. Suppose at some point the circuit cut. There is a cut in the circuit. Then what will happen? Current will decrease. Then the inductor will always try to oppose, the EMF will try to oppose the change of that current, or the decrease in current. Okay, so anyways, you think like mass or rotation, moment of inertia, that is, it will always try to oppose the current state. Sorry, it will always try to oppose the change of current state. Here also the same. If current is increasing, then it will try to oppose that. Then current is decreasing, it will try to oppose that as well. So you can think that the analogous to mass in this circuit, in this EMI, in inductance is the thing which is analogous to mass or moment of inertia. Okay, so I think you got it, and we will discuss about the self-inductance of solenoid. Okay, self-inductance of solenoid in the next video. Okay, thank you.